Hello guys, in this video we are going to be looking at the mole concept and Avogadro's number as a fundamental unit in chemistry. This topic forms the basis of most calculations in chemistry, as many do find it difficult to solve problems related to this topic. So here I'm going to be walking you through the introduction to mole, Avogadro's number, molar mass and molecular mass, and the various equations that we often use in mole concepts. So let's get started. What is a mole of a substance? The mole of a substance is defined as the amount of substance which contains many elementary entities as there are in 12 grams of carbon-12. So that means whenever we are making use of the mole, we must always specify on the type of entities that we are talking about, because we have different entities in chemistry. We have atoms, molecules, particles, ions, radicals, and so on. So when we are making use of the mole concept, we must specify the type of entities as we can see them on the screen. That means, for example, we have what we mean by 1 mole of chlorine atom. Here we say mole. Now we mention mole, we also mention the entity that is related to, which is atom. Another example is 1 mole of sodium ions. In 1 mole of sodium ion, we have mentioned it that here we have mole and we also have ion, which is our entity. Let's look at another example. 1 mole of oxygen molecule. That means in oxygen molecule, said we have mole and we have mentioned the entity, which is molecule. So whenever we make use of the mole, then there must be specification on the type of entities we are talking about. This is what we mean by mole concept. Now let's look at an important key point regarding this mole of a substance. So 1 mole of a substance has a mass which is in gram or kilogram, which is also equal to the atomic weight of the substance. This is the key point we use in solving questions. Let's try to analyze it. Let's take, for example, the atomic weight of chlorine atom is 35.5 atomic mass unit, or we simply write as U. If this is the atomic weight of chlorine, which is also representing the atomic mass of chlorine, because in chemistry, atomic weight and atomic mass, they are the same thing. We have already said that 1 mole of any substance has a mass, and the mass is equal to the atomic weight. That means if this is the atomic weight of chlorine atom, then we can say that the mass of chlorine atom is also 35.5, but it is now expressed in gram. Now 1 mole of any substance is equal to the mass as well. As we can see there, 1 mole is equal to the mass, which is in gram. So in short, we can simply write it as 1 mole of chlorine atom is equal to the mass, which is 35.5 in gram. Let's look at another example regarding this key point. We say example 2. Let's talk about molecule. The molecular weight of oxygen molecule. Oxygen molecule is twice oxygen atom, O2. The molecular weight is going to be 16 times 2. If this is the molecular weight, then we can say that the molecular mass, which is the same as the molecular weight, molecular mass of oxygen molecule, which is O2, is also 32 in gram. You said that is mass is equals to the atomic weight if it is atom. Now, in terms of it is molecular weight. Now that I've gotten the molecular mass of O2, which is oxygen molecule, then we can say that 1 mole of oxygen molecule is going to have a mass which is 32 grams as well. So this is what's meant by this statement. Now let's look at Avogadro's number. Avogadro's number is the number of entities present in 1 mole of a substance. We have already discussed that anytime we make use of the mole, there must be a specification on the entities we are talking about, because the entities can be atoms, molecules, ions, particles, and so on. So the number of atoms that we have in 1 mole of a substance is known as Avogadro's number. The number of molecules that we have in 1 mole of a substance is also known as Avogadro's number. The number of ions, the number of particles in 1 mole of a substance, is known as Avogadro's number. Now, how is this Avogadro's number related to the number of moles? Before that, the symbol for Avogadro's number is Na, and it is given as 6.023 exponential, 23 exponential 23 entities per mole. That means it can be 6.023 exponential 23 atoms per mole. It can be 6.023 exponential 23 molecules per mole, ions per mole, or particles per mole. Let's say we have hydrogen atom. In 1 mole of hydrogen atom, how many atoms of hydrogen can we get in 1 mole? That is 6.023 exponential 23 atoms of hydrogen can be found in 1 mole. Another example is if we have 1 mole of chlorine particles. In 1 mole of chlorine particles, how many particles of chlorine can be obtained in 1 mole of chlorine particles? We are going to be having the value to be 6.023 exponential 23 particles per mole. That is what's meant by Avogadro's number. So we can also call it Avogadro's constant, and the unit depends on the entities we are talking about, which can either be atoms per mole, molecules per mole, ions per mole, particles per mole, depending on the entities they are specified in the mole. So we have looked at Avogadro's number and the mole. Let's consider the molar mass and molecular mass of a substance. But before that, let's try to understand what we mean by substance in chemistry. The chemical substances we have are majorly into 2. First one is molecules, and the second one is compounds. They are the major substances that we have in chemistry. Now let's try to understand what we mean by molecules. Molecules are formed when we combine atoms together, atoms of elements together. We are going to get molecules. For example, oxygen plus oxygen will give us O2. This O2 is a molecule. It is formed by 1 oxygen atom, another oxygen atom, and 2 oxygen atoms combined together to give us 1 molecule of oxygen. Another example is hydrogen plus hydrogen will give us H2. Here we have formed this molecule H2 by combining 1 hydrogen atom with another 1 hydrogen atom to give us 1 molecule of hydrogen. So the examples we have discussed now, they are regarded as homonuclear molecules. That's the first type of molecule, homonuclear molecule. What are homonuclear molecules? As the name implies, homo. That means they are molecules formed by the same element. If I combine the same elements together, we are going to obtain homonuclear molecule. And we have discussed that in this example above. That is O2, that is O2. O2 is formed by oxygen atom and another oxygen atom. Hydrogen molecule, we have it as one hydrogen atom and the other as hydrogen atom. Here we have it as molecule. Now we have another one as, for example, O plus O plus O. And that gives us O3. This is homonuclear molecule. This molecule formed here is homonuclear molecule because we have combined atoms of the same element, 3 atoms, that is one oxygen atom, and another oxygen atom is giving us oxygen molecule, which is ozone, O3. So homonuclear molecules are formed by the same element. Now let's look at heteronuclear molecules. What do we mean by heteronuclear molecules? Heteronuclear molecules are formed by different elements. For example, hydrogen plus oxygen, that will give us H2O. H2O is heteronuclear molecule because it is formed by 2 hydrogen atoms. This is one hydrogen atom, another hydrogen atom, and one oxygen atom comes together to form heteronuclear molecule, which is H2O. So H2O is a molecule which is known as a neutral molecule. Another example is having oxygen plus oxygen plus oxygen, and that gives us SO2. SO2 is a molecule that is formed by 1 atom of sulfur and 2 atoms of oxygen. Give us this molecule. Let's take a look at the last example. Is when we have carbon plus oxygen, and that will give us CO2. CO2 is a molecule that is formed by 1 atom of carbon and 2 atoms of oxygen to give us CO2. Another one is if we have hydrogen plus sulfur, and that gives us H2S. So H2S is also a molecule formed by 2 atoms of hydrogen and 1 atom of sulfur. So we have discussed homonuclear molecules that they are formed by the same elements, while heteronuclear molecules are formed by different elements. Now let's look at another class of substances called compounds. We said we have 2 major areas of substances, the molecules and the compounds. So what are compounds? What are chemical compounds? Chemical compounds are formed by atoms of the same and different elements. For example, we have hydrogen plus sulfur plus oxygen to give us H2SO4. So this is a compound because it is formed by different elements and with different number of atoms. That's what we mean by compounds. We have another one, CaCO3 is a chemical compound because it is formed by calcium, Ca formed by carbon, formed by oxygen, and oxygen, and we regard this as compound. With what we have discussed, it will help us to understand what's meant by molar mass and molecular mass. So let's look at molar mass of a substance. Molar mass of a substance is defined as the mass of 1 mole of the substance. Take for example, we have H2O as a substance now, which is a heteronuclear molecule. We can get its molar mass from its atomic masses. That means what is the atomic mass of hydrogen? By approximation, it is 1.0. Then oxygen is 16.0 by approximation. In terms of gram, that means the molar mass of the substance H2O is going to be equal to The mass of hydrogen is 1, but we have 2 of it, plus oxygen 16, and that gives us 18 gram per mole. That's to tell us that in 1 mole of H2O, what is the mass of H2O? Let's say this is H2O and we are using it as 1 mole. I mean, in 1 mole of H2O, what is the mass? The mass is 18 gram. Molar mass is average unit of gram per mole or kilogram per mole in some cases. So let's look at examples. Let's look at how to solve questions on molar mass. So let's work out the examples that we are seeing on the screen. We are going to solve just 2 out of it. You can send your answers or solutions through the comment section. I would like to see your answer through the comment section. So let's start with the first one, which is NaOH. We are given the atomic weight of the elements involved. So the atomic weight of sodium is given as 23, oxygen is 16, hydrogen is 1. So let's get the molar mass of sodium hydroxide. That will be giving us the sodium is 23 plus oxygen is 16 plus hydrogen is 1, and that gives us 40 gram per mole. So that means in 1 mole of sodium hydroxide, what is the mass of sodium hydroxide? And that is 40 gram. Now let's work out Al2SO4 3.5H2O. How are we going to do this? To solve this, it means that we have a substance Al2SO4 3 and .5H2O. This means that we are having 5 volume of water. 5 volume of water has been added to this substance. So molar mass of this substance, mass is going to be equals to aluminium is 27, but we have 2 of aluminium plus this 3 that we are seeing. This 3 is affecting SO4. It means that we are having SO4 in 3 places. SO4, SO4, SO4. So for us to be able to deal with this, since the 3 is affecting SO4, we can just write as 3, then we will now solve this. That sulfur is 32 plus oxygen is 16 times 4. We are through with that. Dot doesn't mean that we have to multiply it. Dot means we have added 5 volume of water to this substance. That means we are going to write it as plus 5 is also affecting H2O. Hydrogen is having atomic weight of 1. Then we have 2 of hydrogen plus atomic weight of oxygen is 16. And in that case, we're going to have our answer to be. So let me know the solutions. Let me know your solutions regarding the other questions through the comment sections. So let's look at molecular mass. Molecular mass is defined as the mass of a molecule. As the name implies, we can get the molecular mass by adding the atomic weight of the atoms of the elements involved in that molecule. For example, if we have O2, O2 is homonuclear molecule, and we can get the molecular mass or the molecular weight. How can we do this? That means for oxygen atom, don't forget before that, O2 is formed from O and O. They are the one that give us O2. So as a result of that, one oxygen atom is having atomic weight of 16 gram. The other oxygen atom is also having 16. So if we add these two together, we are going to be having 32 gram as the molecular mass of O2. So molecular mass is related to molecules, either heteronuclear molecules or homonuclear molecules. Another example is if we have a nitrogen molecule. In nitrogen molecule, the molecular weight or the molecular mass is going to be the addition of the atomic weight of the elements involved. N2 molecule is formed from two different atoms, which is N plus N. So in that case, we're going to be having the first N is 14. That's the atomic weight of nitrogen. The second is also 14. And when we add it together, we're going to be having 28 gram. So the unit for molecular mass or molecular weight is always in gram. You can always obtain it from the addition of the atomic weight of the atoms that are involved in the molecules. So let's look at illustration on how to solve molecular mass problems. You can feel free to pause the video so as to try this. I'm going to be solving two for us, so we can provide our answers to the comment section so I can check it out as well. So let's look at the first one, which says H2S. As we know that H2S is a molecule and it is considered as a heteronuclear molecule. It is formed by two atoms of hydrogen and one atom of sulfur. What is the atomic weight of hydrogen? That is 1 gram. The atomic weight of sulfur is 32 gram. So the molecular weight or molecular mass of H2S is going to be given as hydrogen is 1 times 2 plus sulfur is 32, and that will give us 34 gram. So the molecular mass of H2S is equal to 34 gram. And we said we can obtain the molecular mass of any molecule by adding the atomic masses together. So let's look at another example. Let's consider third example, that is HCl. To get the molecular mass, we said we need to add the atomic masses together. The atomic mass of hydrogen is 1, while the atomic mass of chlorine is 35.5, and that will give us 36.5 gram. Now let's look at the various equations we often use in solving problems related to Molar concept and Avogadro's number. The equation says that mole is equals to mass over molar mass or molecular mass. When do we make use of this equation? We use the equation whenever we are given the mass of the substance. We have learned how to get the molar mass or molecular mass of any substance. So we can simply write this equation by saying N is equal to M over mm. That's to represent molecular mass or molar mass. We make this as equation 1. So let's look at some examples to help us understand how this equation works. As you can see on the screen, the question says calculate the number of mole in 32 gram of SO2, 40 gram of CO3, and 60 gram of CO2. I'm going to be solving the first equation to help us understand how to make use of the first equation. So you can send your answers to the B part of this question and the C part through the comment section. I'd like to see your solution through the comment section. So let's start with the first one. There are two approaches we can use. It's either we use the formula method or we use stoichiometry by comparing the values together. So let's start with formula method. According to the formula we can see on the screen, which is this, it says number of mole equals to mass over molar mass. That means we need to get the molar mass of SO2. Molar mass of SO2, that's going to be sulfur, as we have discussed, that is 32 plus oxygen is 16 times 2 if we solve for, you are going to be getting 64 gram per mole. Since we have gotten the molar mass and the mass of SO2 given in a question, that is 32 gram. So we can therefore use the equations that says using number of mole equals to mass over molar mass. So we are going to be having the value to be N is equals to, the mass given is 32 gram, while the molar mass we have solved is 64 gram, and that will give us 0.5 mole of SO2. This simply means that if the mass is 32 gram, the number of mole is going to be 0.5 mole. Now let's use another approach to solve this same question. Alternatively, we can solve it by using the assumption that we have discussed in the beginning section of this topic. We say that 1 mole of any substance has a mass which will either be the molecular mass or the molar mass of the substance. So 1 mole of SO2 is having a mass of 64 gram. That means in 1 mole, the mass is 64 gram. And we have there, if 1 mole of SO2 is giving us a mass of 64 gram, therefore X mole of SO2 will now be equals to 32 gram, which is the one given in the question. This method we have used, can write it first by saying 64 gram of SO2 is equal to 1 mole. Therefore, 32 gram of SO2 will now be equals to X. It doesn't change the solution of the question. You can write it anyway. So that way we are both correct. Now the next thing is to cross multiply and solve for it. So that will give us 1 times 32 is equal to X times 64. So that means we are interested in X. So we divide side by 64. X becomes 32 over 64. And if you look at it, we are arriving at the same answer that we have here. This solution, we have arrived at the same thing, so which is still going to give us 0.5 mole. So this is explaining the fact that if 64 gram is giving us 1 mole, then 32 gram give us 0.5 mole. So for the B and C parts of this example, you can send your answers through the comment section and let me check it out for you. So let's look at the second equation regarding the mole of a substance. So the second equation that we have for mole of a substance is number of entity over Avogadro's number. So what's the symbol for mole? It is N equals to number of entity. We said that's capital letter N. Then Avogadro's number is Na, and that's equation 2. And we have said that Avogadro's number is always 6.023 exponential 23 entities per mole, which can either be atoms per mole, molecules per mole, and so on. So that is entities per mole. That's a unit. So when do we make use of this equation? We use this equation whenever we want to solve for mole and we are given the number of entities, either atoms, molecules, particles, ions, or radicals. Once we are given this, in this case, we are not given the mass, we are given the number of entities. Then we are going to be making use of this equation, or we use stoichiometry as well to solve it. So let's look at examples to help us understand how this second equation works as well. So let's look at all these examples that we are seeing on the screen. How many moles are there in 3.04 exponential 22 atoms of chlorine? We have 6.25 exponential 23 sodium ions. Then we have 1.24 exponential 24 hydrogen particles. That's particles of hydrogen. So how are we going to solve this? I'm going to solve the A part for us. Then you try to solve the B and C part and send your solution through the comment section. To solve this, let's take a look at it together. We are going to be using the equation. Since we are given the number of entities, the entity involved here is atoms. So our n is 3.04 exponential 22. So since we are given the number of entity, which is atom, the Avogadro's number is 6.023 exponential 23. In this case, it's going to be atoms per mole. It's going to be the unit. Sometimes we write it as 6.02 in approximation. That depends on the Avogadro's constants we are given. Now we can make use of our equation that says number of mole equals to number of entities over Avogadro's number. Equation 2. In this case, we can solve for it by saying n is equals to number of entities involved is 3.04 exponential 22 over 6.023 exponential 23. So we are going to be having 0.05. This simply means that if the number of atoms is 3.04 exponential 22, the mole is 0.045, or we can say that in 0.05 mole, the number of atoms there are 3.04 exponential 22. Let's use another approach to solve this same question. Remember, we said that in 1 mole of a substance, there are 6.023 exponential 23 number of entities of that substance. So let's look at it. That is to say, 1 mole of chlorine atom, in 1 mole of chlorine atom, we are having 6.023 exponential 23 atoms of chlorine. Therefore, let's use another letter. Y mole, Y is representing unknown. Y mole of chlorine, which is in atom, is going to be equals to, the standard value is 3.04 exponential 22 atoms. So here we try to cross multiply. We are going to be having it to be 1 times 3.04 exponential 22 is equals to 6.023 exponential 23 times y. We are interested in getting the value for y, so we have to divide both sides by 6.02 exponential 23, and that will give us 1 times 3.04 exponential 22 rather over 6.023 exponential 23 equals to y. You notice that we arrive at the same values we are having here. This particular solution we are having here is the same thing we are getting here. So we have used different method. We use formula method, and that will still give us y to be equals to 0.05 mole of chlorine. So we can send our solutions through the comment section to be sure maybe we have the same answer. Now let's look at the last equation for mole of a substance, which is the third one. So the third equation says mole equals to volume of gas over molar volume. N is equals to volume of gas over molar volume. That's the third equation. Now, what is the meaning of molar volume? Is similar to the molar mass. Is the volume of 1 mole of a gas. It's mostly connected to gases. When we are dealing with questions related to volume of gases involved, let's say in CO2, we are interested in getting the volume of CO2 that is involved. We'll make use of this equation. Now, the little challenge we are going to be having here is the usage of VM, because the molar volume, we have it in different values. Let's look at the values for molar volume. We have molar volume to be 22.4 in dm cube per mole. We have molar volume to be 22.4 liter per mole, simply because one dm cube is the same thing as 1 liter. So we write 22.4 dm cube is also known as 22.4 liter. So another value for molar volume as VM is 22,400 centimeter cube per mole, while the other one is in meter cube, and that is 22.4 exponential minus 3 meter cube per mole. So these are the values for the molar volume with different units, and that depends on the volume of the gas we want to solve for. If the volume of the gas is needed to be in dm cube, we can use molar volume in dm cube. When needed in liter, we make use of the one in liter. When the volume of gas is needed to be centimeter cube, we make use of the molar volume in centimeter cube. But when we have to solve for the volume of the gas in meter cube, then we can make use of this last equation, this last value rather. So now let's look at how this equation 3 works. Like I said, it's mostly used when we are interested in getting the volume of the gas that is involved in the reaction or in the process. So let's look at examples under it as well. Consider these 3 examples that we have. We are given the volume of the gases involved, so we'll not be able to make use of the first equations that says mass over molar mass, or the one that say number of entities over Avogadro's number. We'll be able to use this one since we are given the volume of the gas involved. So how are we going to work it out? I'm going to be solving the first example for us. You can send your answer to the B part and the C part through the comment section, so that I can help you cross-check it. So the parameter given, which is the volume of the gas involved is O2 and its volume is 16.4 dm cube. Now, since we are given the volume of the gas to be in dm cube, then we are going to be making use of the molar volume in dm cube. If we use other value of molar volume, that means we need to be converting. So in order not to convert or stress ourselves, that's why I've helped you to do the conversion, the conversion of the value of the molar volume in different units. So the molar volume you are going to be using based on the parameter given is in dm cube. So you are going to be using the molar volume in dm cube, and the one in dm cube is 22.4 dm cube per mole. If this is the molar volume, then we are going to make use of the equations that says N is equals to volume of the gas over molar volume, which is the standard value of equation 3. So we are going to be having N equals to volume of the gas is 16.4. If you want to work with units, you can work with the units, but for simplicity sake, I'll just be putting the values as 22.4 in dm cube per mole rather. Okay, let's try to work with the units for us to be sure we are on the right path. So in this case, dm cube, we cancel dm cube, so we are going to be obtaining our number of mole to be. So this is what we are going to be having. That means if one mole give us volume of 22.4 in dm cube, then 0.732 mole will give us a volume of 16.4 in dm cube. Let's try to solve it using our alternative method. We can use stoichiometry as well by saying that 1 mole of a substance, in this case we are dealing with a gaseous substance, 1 mole of O2 is having a volume of 22.4 dm cube, which is the standard value. Therefore, let's use another letter. Y mole of O2 will occupy a volume of 16.4. Like I said, we can reverse the process by saying 22.4 dm cube is equivalent to 1 mole of oxygen gas. Then 16.4 dm cube now equals to Y. And anyway we have done it, we all have the same answer. So in this case, we can cross multiply by saying 1 times 16.4 is equals to 22.4 times Y. So when we try to make Y the solved formula, we have to remove 20.4 because it is attached to Y. So divide both sides by 20.4, that gives us 16.4 over 22.4 is equals to Y. And as you can see, we have returned back to this area. We have returned back to this place. We'll see 16.4 over 22.4, just like we have used in the formula method. So the value for Y, which represents our number of mole, is going to be 0.732 mole. So these are the equations that we use in solving questions related to mole concept and Avogadro's number. In the coming video, we are going to be looking at other areas of calculations related to mole concept and Avogadro's number, which is known as concentration of solution and its unit. In this coming section, I'm going to be discussing how we can solve mole when we are given the concentration of the solutions and other parameters related to the mole. So let's try to summarize what we have learned. We have learned that mole is equals to mass over molar mass. Then we have also learned that mole is equals to number of entities over Avogadro's number, and at the same time mole is equals to volume of the gas over molar volume. These are the three equations that we often make use of in solving questions related to mole. Sometimes we can be given parameters from this part and we are asked to solve for the mass or the molar mass, and we can also be given parameters for mass. We want to solve for the number of entities, or we are given parameters for the volume of the gas and we want to solve for number of entities or mass. So the questions can come in different areas, in different angles, depending on the parameters we are given, and we can mix the equations together as well. So in the next video, we are going to be solving problems related to these three equations simultaneously. So thank you for watching the video. Kindly subscribe to my channel so as to get notified whenever new videos are uploaded.